Good day and welcome. This lesson is for grade 8, grade 9 and grade 10 learners as introduction to analytical geometry and what you will be dealing with. Firstly, as background to analytical geometry, the following things should already be in your toolbox. Our prior knowledge should be the number line where we know and are familiar with positive as well as negative numbers. We should be at this stage familiar with the Cartesian plane where we have the x-axis and the y-axis. We should have worked with quadrants and their properties, know of Pythagoras, and for those who can't remember, the square on A plus the square on B is equal to the square on C, if C is the hypotenuse, and this should be known contextually. Measurement with a ruler starting at 0, and then alternatively also a ruler that is broken to start measuring at any other number and still calculating the correct distance. Firstly, as background and introduction, I would like to say trigonometry was introduced in the 1630s and it is important in mathematical development. It laid the foundations for modern mathematics as well as it aided the development of calculus. René Descartes in 1596 to 1650, as well as Pierre de Fermat 1601 to 1665, were French mathematicians who independently developed the foundations for analytical geometry. So let's look at what the word analytical geometry means to us. The word geo is derived from two Greek words, geo meaning earth and metron meaning measurement. In layman's terms, it means the measurement of the earth, the study of coordinate geometry from an algebraic perspective. We work with coordinates on the axis. So the horizontal axis is known as the x-axis, the vertical axis is known as the y-axis, and O is my origin, where the two axes cut each other. The quadrants are then created as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In the first quadrant, my coordinates of P will be x of P and y of P. In quadrant 2, my coordinates will be negative x of P and positive y of P. In my third quadrant, I will have negative x of P and negative y of P. In my fourth quadrant, I will have positive x of P and negative y of P. At this point in time, we should be familiar with our ordered number pairs. Any coordinate on that Cartesian plane has got an ordered number pair, a x value with a corresponding y value. The x coordinate is called the abscissa and the y coordinate is called the ordinate. It's important to note if my x coordinate is 0, that means the point lies somewhere on the y-axis. And when my y coordinate is 0, the point lies somewhere on my x-axis. You must understand, when we work with distance from Q to P, then the distance from Q to P is the same as the distance from P to Q. When I say that 3 points are collinear, it means those 3 points lies on the same line, whether the line is horizontal or whether the line is vertical or whether it is a slanted line. Concurrent lines are lines that meet in one common point. So if I speak of ED and CF, they meet in the point G. So those two lines are concurrent. When we speak of a median or centroid of a triangle, we speak of a line that will cut two concurrent lines in the center of the triangle, meaning the distance from that point to any vertex of the triangle will be exactly the same. All three x coordinates are added together and divided by 3. All three y coordinates are added together and divided by 3. That will give me the coordinates of the centroid or the median of that particular triangle. This is also found when we have a circle inside the triangle. Then we talk about a in-center circle. Or we can talk about an X-center circle. The one circle is inside and the other circle is on the outside. So let's recap and get to the fun stuff. When we work with a Cartesian plane, the first thing that we need to realize when we work with our x-axis, as we move away from 0, the numbers increase. 1, 2, 3, 4, 5. As we move to the left of the 0, our numbers decreases. -1, -2, -3, -4, -5. But the same sequence that is followed on the right hand side is also followed on the left hand side. When we move away from the center, we count 1, 2, 3, 4, 5 going up, and the same distances must be represented for all these values. So when I go to the bottom of 0, it will also be -1, -2, -3, -4, etc. When we work with our Cartesian plane, do not forget to label the horizontal axis as the x-axis and the vertical axis as the y-axis. We know that this will be the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now we will look at plotting, and we're going to plot the coordinates for A, which is 2 and 1. So on the x-axis, I go to 2. My x value is 2. So I go on 2, and there's a imaginary line. Then on y-axis, I go to 1, and I go and I make a imaginary line. And where those two imaginary lines meet, I will place my dot to indicate the coordinates of point 2 and 1. Now I need to label this point. Now we're going to plot the coordinates of C, which is 0 and 1. So I go on my x-axis to 0 and on my y-axis to 1, and I plot my coordinate as 0 and 1, and I label that coordinate as C, 0 and 1. I plot another point. Let's plot point K, which is -5. So I go on my x-axis to -5 and on my y-axis to -2. So no longer am I going up. I need to go down 2 places. I plot my point and I label my point. Now I'm going to give you some homework. Try to plot the following points: B, D, E, F, G, H, I, J, and L. That is your homework. Trust you will do well with this. We'll see you in the next lesson. Right, to conclude, thank you very much for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Do not forget to like, subscribe, and turn on your notifications to be notified when the new video is uploaded. Please share if you found this useful. Thank you. Goodbye.